Hey, good evening, everyone. Welcome to O-level physics lesson. My name is Mr. Chu. Today is Tuesday, 22nd of March. And topic that we're going to do today is static electricity, and we'll be going through question this week. Okay, all of you take a look at question 28. And you may begin, you may do the question and then give me the answer. Okay, Chelsea got it correct. Ethan got it correct. How about the rest of you? Yuting correct. Yuting, you put a question mark. Does it mean that you are not sure? Okay. Okay, Howry and Oscar, how about you? What's your answer? Okay, so you think you need me to explain this question? Oscar and Howry, hello. Okay, so initially they are in contact. Oscar, Howry, are you all facing a problem? Can you please PM me the answer? Okay, so when they are in contact, it means that electrons are free to move, okay, left and right. Okay, so when you put a positive charge rod near X, okay, what happens is that it will induce, okay, Howry, well done. Okay, so what happens will be, it will induce the charges. Okay, so what happens is when where is near the positive, it will become negative. Okay, hold on, my pen has no power. To charge my pen. Okay, so where is near will be negative, and then where is far is positive. Okay, it's very ugly down here. Let me redo. Okay, Ryan is here already. Oscar, are you there? Can you please give me the answer? Okay, so where is near on the left will be negative. On the far end will be positive. Is that clear? Okay, and that is before the X and Y are moved away. Okay, so when you actually put the positive near X, the left side of X will become negative, the far end of Y will become positive. Okay, so on the left side, there will be more electrons. On the right side will be less electron. After that, you move the sphere apart. Okay, once you move the spheres apart, okay, the electron cannot jump from one sphere to the other anymore. Okay, so this 3 negative itself, after you remove this positive charge rod, this sphere, these 3 negative will all spread out. Okay, what do I mean by that? Okay, once you move them away, okay, once you move them away, the 3 negative, okay, will become like this. Okay, the 3 negative will spread out. Okay, and then the 3 positive here will spread out as well. Okay, so the answer for this question is D. Okay, well done. All of you got it correct. Okay, well done. Okay, Ryan, okay, look at this question quickly and then you can do the next question. Okay, let me go to the next question. Okay, all of you do question number 30. Yeah, I realize this thing is not very well done. Yeah, it's actually very bad. Okay, never mind, you all do question number 30 first. Okay, let me change this. Okay, this is not a very good scan. Okay, hold on. Okay, can all of you do question number 30? You all may begin 30, and then let me know in your chat what's your answer. Okay, Qiao Qing has given me the answer very quickly, and it's correct. Well done, Qiao Qing. Okay, how about the rest of you? Okay, if you're in the exam, okay, what I will do is I'll highlight some keyword. Okay, I'll highlight words like negative. Okay, and then direction of the electric field. So these will be some keyword that I will actually highlight. Okay, how about the rest of you? What is the answer for this question? Can you please DM me your answer? Yufeng, well done. How about the rest of you? Ryan, try again. Okay, remember I highlight the word negative. There's a reason to that. Okay, Oscar, well done. Okay, Ryan, you got it right now. Yiting, you are correct. Okay, who's the last student? Okay, so most of you got it correct. The answer is horizontally to the left. Okay, why is it to the left? Okay, so let me show you. Hold on. Okay, let me show you the field. Okay, the field is horizontally to the left. What does it mean? Okay, so the field will be like this. Correct? So this is the electric field. So what it means is that if I put a positive charge here, it will go in the direction to the left. Okay, but in this case, we actually put a negative charge in the field, so therefore it moves to the right. Okay, so the electric field, the direction is to the left, is actually indicating what will happen if you put a positive charge, okay, in this field. Okay, you put a positive charge, it will actually move to the left. But in this case, you're putting a negative charge going to the right. Okay, so you actually move to the right. So the answer is A, okay, horizontally to the left. Okay, well done to all of you. Let's go to the next question. Okay, let's do question number 28. Okay, you all may begin. Okay, Ryan got it correct. Well done. Yiting, correct. Very good. Okay, Qiao Qing got it correct. Well done. Okay, how about the other three of you? Okay, Yufen, you got it correct as well. So I left with Oscar and Hao Rui. Oscar incorrect. Okay, so for this question, okay, when you have two material and you're trying to make the two material charge by rubbing with each other. Okay, so for this question, the word is to make both material charge by friction. Okay, so do you remember what kind of material can we use, okay, to actually induce charging by friction? Okay, both the material cannot have free electron. Okay, Oscar, both of the material cannot have free electron. Harry, are you there? Okay, so if both cannot have free electron, okay, why cannot have free electron? Because if you have free electron, if you were to rub it, it may get charged. But once you remove your hand, because the electron can move freely, you'll go back to the neutral charge again immediately. Is that clear? Okay, so for two material to get charged by to be charged by induction by friction, okay, both material has to be a non-metal. Okay, Oscar, well done. Okay, so both material have to be a non-metal. So you look at these four options. Which of these four options where there are no metal in the both rod and thin sheet? Okay, Oscar, you got it right. Howry, are you there? Yeah, today giving me the answer very slow. Okay, well done. So all of you got it right now. So the answer for this is D. Okay, well done. Let's continue to the next question. Okay, very good. Next question. Okay, you all get it? You all understand how to do this type of question? So for rubbing is actually for rubbing question is actually yeah, both material has to be non-metal. Okay, now all of you do question number 30. Okay, again, let me give you the keyword. Y is matter. Okay. Then it is earth. Even incorrect. Qiao Xing, well done. Yi Ting, well done. Okay, Hao Rui, very good. So I left with Ryan and Oscar. Ryan, incorrect. Oscar, how about you? Ethan, do you need help? Ryan, do you need help? Oscar, are you there? Okay, Oscar, well done. Okay, let me explain this question to both Ryan and Ethan. Okay, so what happened is when you move close, okay, what happened at first when you move close? Okay, let's say now they are very close. Now they are very close. Okay, close. Okay, so what happened is on the left side of the Y will be at the negative of the left side of the Y will be attracted to the positive, correct? And then what happened to the right side? It will be positive itself. Okay, then the next thing that happened will be you actually earth the Y. They are still close. Okay, they are still close. Okay, but you earth the Y. What does it mean? Well, Ryan, you're looking at me or looking at my background? Okay, at first I was also a little bit confused. If I earth the Y, do I put it on the right side or on the left side? Okay, it doesn't matter. Okay, it doesn't matter where I earth it. Okay, but what's happening will be, regardless of where I earth it, the side that is near the X will always be negative. Okay, because negative attracts positive, and then the positive repel positive. Is that clear? So no matter how you earth it, the side that is nearer to the X will always be negative. Clear so far? Okay, so this Earth itself either supply unlimited electron or it absorb unlimited electron. And everything will always try to be as neutral as possible. Okay, so I mentioned to you earlier on that the left side will always be as negative as possible due to the closeness to X. So what happened to the right side will be, the right side here will be neutralized. Okay, so what happened is electron will actually move from the Earth to the sphere and then neutralize all the positive. Okay, once you do that, okay, once you do that, then you move the X far, far away. Okay, then you move the X far, far away. So I remove this, and then finally, okay, you'll only be left with negative throughout. Is that clear? Okay, so this is what this question means. So for Ryan and Yufan, you understand the explanation? Okay, Ryan, Yufan, if you understand, give me a thumbs up. Can Ryan, Yufan tell me what were you thinking? Can you share everybody? Okay, by chat, share everybody. what were you thinking at first when you were doing this question? So that everybody know what were you thinking, and then don't make the same thinking in future. Okay, so for Ryan and Ethan, can you share with us why did you choose another answer previously? Just type out in the chat and then share everyone. Okay, can you share with everyone? Okay, never mind. Ethan was saying that she doesn't know that the earth wire was connected to the right side of Y. Okay, but regardless where you put the earth wire itself, the left side of Y will always be negative because it's near the X. Okay, it's near the X. Is that clear? All right, how about Ryan? Can you share with us why you made a mistake previously? Okay, Ryan, do you know why your this thinking is inaccurate now? So all of you actually go and read Ryan's explanation. He thought that when you earth something, the electron actually disappear. Okay, so when you earth something, it can either absorb all electron or it actually supply more electrons. Okay, so it's either way. So it's not just taking away electrons, it can be also the other way. Okay, I'll do question number 29. You all may begin. Okay, you are answering very fast. Yuting, Yifan, and Ryan, correct? Yuting asked me a question. Your question is correct. Okay, my answer to your question is yes. Hao Rui and Qiao Xing, incorrect. Oscar also incorrect. If you all remember my last two lessons, I actually mentioned something. Okay, when we break down the matter to its component, there's the neutron, there is the nucleus, the neutron, proton, and electron. Do you remember that? Okay, so there is a proton. Okay, not nice. Okay, so do you remember this thing I told you earlier on? Okay, so the nucleus that consists of proton, the positive charges, and the neutron, they are stuck there, they do not move. Okay, in a metal, the electron can be moved freely. Clear? In the non-metal, most of the electron will not be able to move. A small amount can be moved, and that's called induction. Okay, you are charging your non-metal by induction. Okay, but for a metal itself, the electron can be moved freely. Okay, so for this question, what will I highlight? I'll highlight the word metal and then another metal. Okay, so only the electron can be moved freely. Clear so far? So positive charge cannot move. Okay, positive charge cannot move. Okay, positive charge cannot move. Do you remember this? Okay, positive charge will always stay with the atom. It's only the electron, the negative charge, that is able to move. Clear so far? Okay, so because positive charge cannot move, based on this knowledge, you know that A, B, and D are actually wrong. Okay, so the only correct answer is C, but let's understand C a bit better. So when you move Y close to X, okay, now don't care about the charges, the positive or negative charges, but what happened is on the right side become negative, on the left side become positive. So what's happening here? Remember I told you the positive do not move. So they are positive on both sides, but the positive do not move because the negative on the left side move to the right side. So the right side has more negative, even though the positive are still there. So therefore, there is more negatively charged. On the left side, there are less electron. Okay, so it becomes more positively charged. And therefore, the answer for this is C. Clear? Okay, so for Hao Rui, Qiao Xing, and Oscar, if you understand my explanation, can you give me a yes reaction? If you still don't understand, give me a no reaction. All right, perfect. Let's move on. Okay, so are you all clear with this topic or not? Remember, I told you all before, right? This topic is a topic that I always get confused when I was a student. I hope I made myself very clear to you all. This topic actually is not very hard. Once you know the basic concept, it's actually very easy because there's no calculation for this topic. But some of you, if you're like me, like mathematics, you all may actually like calculation. So can you share with me, do you prefer calculation question or non-calculator question? Okay, do question 30, then 31. Okay, do question 30 first. Now may begin. So Oscar is like me, you prefer to count. So Oscar, in chemistry, you actually also prefer those calculator questions, right? So have you learned organic chemistry? Two, three, four, five, six. Oscar, I don't understand what you mean. You understand chemistry. You mean that for both calculating and non-calculating chemistry, you actually you understand both. Okay. Ryan, you got both questions correct. Well done. Qiao Xing, your 30 is correct. Very good. Yufen, your 31 is incorrect, but your 30 is correct. Well done. Okay, Yufen, you do 31 again. Hey, but Oscar, after going through with me for so many months, did I help you understand physics better? If you realize the way I try to share with you is understanding the concept. Chelsea, your last answer, your latest answer is for 31, right? Yeah, that's correct. Well done. Yiting, both correct. Very good. Hao Rui, you share answer to everybody. Okay, your answer is correct, Hao Rui. Okay, let me go through the answer question. Okay, for question 30, most of you got it correct. Oscar, well done. You can start to hear that my voice is starting to become hoarse again. So what happened to me last week was my throat is very itchy. Yeah, that's the only discomfort I have. But itchy is still okay lah. But when it's itchy, it makes me want to, cough to soothe the itch. So that's what I've been feeling for the past few days. Yeah, I think I haven't been talking much for 2 weeks. So now I talk a bit, my voice become a bit hoarse. Okay, so for question number 30, okay, most of you got it correct. The answer is C. You all need me to go through? Okay, so when you do this question, At first, okay, so for this, what will you do when you go to the exam? Okay, I will do is I'll highlight the word earth, I'll highlight the word matter. Okay, this is the two words that I'll highlight. So at first, okay, the first step, what happen is it will become like this. At first, step 1. Okay, step 2. Okay, step 2, this will be neutralized. Okay, so what happen is the negative will go down to earth. Okay, to neutralize it, the negative will go down to earth. And then finally, when you remove the earth, you're only left with the positive. Okay, so the answer is C. Q will be positively charged because the negative charge have left Q. Clear so far? And then another thing that you need to know, positive charge cannot move. Okay, positive charge cannot move, so you cannot say, so things like this is wrong. Okay, things like this will be wrong. Okay, things like this will be wrong. Clear so far? So if this is a positive, okay, let me redo the whole thing. If the rod is positive, what's happening here? This will be negative on the left side. On the right side will be positive. You cannot say that the positive have left Q. Okay, the positive charge did not leave Q. In this case, what happened is electron comes from the earth to neutralize the positive. Okay, and then after that, what happened is you become negatively charged throughout. Okay, so what would the answer say? You'll say that Q will be negatively charged because negative charge, okay, has moved to Q. Okay, negative charge moved to Q from the earth. Okay, number 31. What always experience a force when placed in an electric field? Okay, the answer for this, no need to explain. The answer is D. Okay, so for these two questions, the answer is C and D. Okay, so in electric field, okay, electric field is where an electric charge experience a force. Okay, so for 31 is their definition. There's nothing much for me to explain. So let me go on to the next question. If you all realize the earlier paper, right, they can squeeze like 3 questions in 1 page. Then in the later paper, the one that is nearer to your ear, they actually squeeze less question to 1 page. So you expect that your exam paper will be thicker because there's less question in each page. That also means that there are also no more diagram. Okay, do question 29. Everyone, do question 29. Ryan, your answer looks correct. Ethan, well done. Yuting, well done. Let me go get a drink. Oscar, well done. Xiaoxing and Xiaoxing, incorrect. How Ray, well done. Okay, Xiaoxing got it correct already. Well done. Okay, so the answer for this is B. Okay. All of you must remember, positive charge always outward arrow. Okay, let me just draw out. Positive is always outward arrow. Negative is always inward arrow. Okay, if we go to a magnetic field, same thing. North pole is always going out. South pole is coming in. So can you remember that? Okay, so if you once you know these two concepts, you'll know that the answer is B. Okay, well done to all of you. Let's continue next question. Okay, do question 29. Okay, you all may begin. Okay, I'll share with you the keyword I will highlight in exam. Okay, Ethan, well done. Ryan, try again. Okay, Yi-Ting, well done. Okay, Xiaoxing, well done. Ryan, well done. Hao Rei, well done. Oscar, how about you? Oscar, incorrect. Yeah. Okay, two of you initially talk about B. Okay, it's very easy to say B. Okay, because you see them moving. Why they move? Because light charges repel. Okay, so so that's the understanding that you all have. But you must remember, both are the same pen. They are both rubbed with the same cloth. Okay, different cloth, but mean identical cloth. Okay, so when you rub a pen, a plastic with a cloth, one of them will become positive and the other one will become negative. Is that clear? Okay, so you cannot say that both attract. Okay, both the cloth and the second pen attract. You cannot say that both the cloth and the second pen repel. Okay, so cloth attract the pen is okay. It's okay to say that. Cloth repel the pen, you can also say that. Okay, then the thing is this, both are the same pen, they should have light charges. Okay, they should be light charges. Okay, so the pen and the pen, you cannot say that they are actually attract. Okay, but why is B wrong? Okay, when both the pen repel each other, it is correct. Okay, that is not wrong. But why is B wrong? So for example, if the pen become positive, both the cloth will be negative. Okay, both the cloth will be negative. So if the pen were to repel the pen, the cloth will be of the opposite charge. It will not repel the pen. Is that clear? Okay, this question, there's no need for you to remember whether does the cloth become positive or the pen become negative. We can just assume, because I also cannot remember. Okay, so you just need to assume that the pen is positive, but you can also assume the pen is negative, then the cloth will be the opposite charge. Okay, that is induction by friction. Clear so far? Okay, so I already explained why A and B are wrong. Okay, and then I also mentioned that the pen can only repel the pen. So the pen cannot attract the pen. So for D is actually incorrect. Answer for this is C. Is that clear? Are you clear about this? Okay, so for Ryan and Oscar, if you understand, give me a thumbs up. The rest of you, if you learn something for this question, can also give me a thumbs up. All right, let's do the next question. Okay, do question number 30. Okay, you all may begin. Okay, so this is metal and this is non-metal. So what happens when you put a non-metal charged rod near a charged metal rod? Chelsea incorrect. Yu Fen, well done. Yu Ting incorrect. Hao Rui, well done. Ryan incorrect. Okay, let me give you another clue. There are 3 negative. Okay, there are 3 negative in the negatively charged rod. So Ryan and Oscar, try again. Okay, Yu Ting, well done. So I'll give you another clue. Your sphere in the end will still be 3 negative because the sphere is touching the insulating mat. So if it's 3 negative, at the end it's still 3 negative. So this one becomes 6 negative. This one becomes neutral. Okay, so A and B are wrong. Okay, so that's what I'm saying. So which one will be your answer? Okay, Ryan, Oscar, Chelsea, well done. Okay, so your okay, so definitely okay, if you know how to do this question, right? Okay, first of all, you know that negative charges repel. Okay, sorry. Light charges repel. Okay, so light charges repel, C will be wrong because you will not get the light charges near each other. Clear so far? Okay, so for this type of question, your answer will be either A, B, or D. Okay, why is B wrong? B is wrong. Okay, B is wrong because your sphere now from negatively charged become neutral. Okay, so therefore B is wrong. Okay, so it's between A and D. Okay, A looks correct. D also looks correct. But which one is the more correct answer? Okay, why is A wrong? Is because at first it is 3 negatively charged. You will not become even more negatively charged. Okay. So there will be no additional electron joining the sphere because the sphere only touching the insulating mat. So there's no contact with other matter. There's no contact with Earth. Okay, so the sphere will not have a more or less electron. Clear so far? Okay, so what this negatively rod does is, okay, on the left side of this thing, okay, what it does is, there are 3 negative, correct? Okay, there are also positive, minus, positive, minus, positive, minus, positive, minus, okay, all over the sphere. So when you put the negative over, all these positive, all these negative will actually move to the right. So on the left, you have some positive. On the right, there are more negative. But overall, the charge of the sphere will still be 3 negative. Okay, so for this question, it's quite badly done. If you understand the explanation, give me a yes reaction. Thank you. Okay, you understand this question better now? Okay, let's do another question. The last MCQ question. I will not be going through last year's paper because the thing doesn't show nicely. 2020. Okay, do question number 28. Okay, you all may begin. Yuting incorrect. Ethan incorrect. How well done. Do you remember what I told you earlier? The side near to the near to the rod will always be the charge. Okay, Oscar, well done. Xiaoxing, Yufen, try again. Okay, Yuting, Ryan got it correct now. Okay, so without the earth, what's happening? Okay, if there's no earth, it'll be something like this. Am I correct? Okay, without the earth, you look something like this. Okay, all of you actually know this. So what happened when I add the earth? Remember I told you the earth can be anywhere to the sphere. So the side that is near this will still be positive. Okay, it will still be positive. Okay, so this one will still remain. Then the side that is further away from the rod, okay, will get neutralized. Okay, so all these will get neutralized. So this itself will actually move away. Okay, and therefore, what's your answer for this question, everyone? Okay, so therefore the answer for this will be A. I know that it looks very confusing. It's like seems very doesn't make sense. Okay, because the earth is like on the left side. Okay, the earth seems to be on the left side. Okay, so what is actually happening here is this. This rod has less power compared to the earth. So you're actually touching another metal part. Okay, so what this thing is, this will have some influence on the left side. Okay, and then almost no influence on the right side because very far away. So on the right side, whatever that extra electron will all be absorbed by the Earth. Okay, so if you understand this question, can you give me a yes reaction, everyone? Okay, good. Let's go through question number 7. Okay, all of you do question 7A part 1 now. Ryan, are you there? How come your name become lighter? Okay, all of you do question part 1. 1 minute. You shouldn't take more than 1 minute to do 1 mark question. You shouldn't take more than 1 minute to do question 7 part 1. Okay, how does a screen become positively charged? Okay, Yu, well done. 1 mark. Okay, this is not a hard question. Can you do quickly? Okay, Howard, well done. Okay, the rest of you quickly do. Yu Ting and Howard, you can look at question part 2 quickly. Chelsea, you need to explain clearly why it become positively charged. So what happened? Anything moved from where to where? Okay, Chelsea, try again. Okay, how about the rest of you? Ethan, Oscar. Okay, Ethan, well done. Well done. Okay, so basically the key point that I want to see from most of you or all of you is this. Okay. Okay, I can't see the word. Okay, there is a transfer of what? Okay, only electron can move. Okay, that's the thing that you need to remember. So there's a transfer of electrons from where to where. Okay. Okay, so there is a transfer of electron from the screen to the soft cloth. Okay, when it's being rubbed. Okay, so there is a net excess of positive charges. In this case, will be protons on the screen. Okay, and therefore the screen is positively charged. Is that clear? Okay, Xiaoxing, well done. Okay, now do part 2. Okay, part 2, the question is 3 marks. Okay, so can you explain why the dust are attracted to the screen? Okay, explain briefly. Okay, Oscar, for your part 1, very well explained. I remember your exam is only 1 mark, so you must think of how to simplify answer. But your answer will get a full 1 mark. Okay, so do part 2, everyone. Why the dust particle get attracted to the screen? So some of you, do you realize like your iPad lah, your handphone lah, or your laptop, you see a lot of dust on your screen. Okay, why is that so? Irritating, right? You see all the dust on your screen after some time. Chelsea, I'll give you only 1 mark out of 3. Okay, and then the reason why, Chelsea, I don't give you the full marks is this. Okay, the question say that the particles are uncharged. Okay, the particles are not negatively charged. The particles are uncharged. Okay, if it's uncharged, why is it still attracted to the screen? Okay, think about it. 3 marks. How many of you need help? Can you type help in the chat? Then I'll give you all the first part of the answer. Anybody need any help for this? Okay, first part is this. You remember that your dust particle is okay, your dust particle is uncharged. Okay, so there is positive, negative all over the place. So if I were to remember, let me have 2 things here. This is the screen. This is the dust. So the screen is positively charged based on the previous question. So after you rub your TV with a cloth, right, your screen will be slightly charged. But after rubbing, you actually attract dust more. Okay, so dust itself, there are positive and negative all over the place. Correct? It's neutral. But when it is near, when your dust is near the screen, okay, what happened? The positive, okay, since the positive cannot move, how will the positive and the negative react? Okay, the positive and negative will, they are unlike charges, it will attract. So what actually happened is, within the dust, okay, within the dust, the negative will be attracted to the left. Clear so far? Let me read some of your question. Okay, so that's the first step. Okay, when the dust is near the screen, the negatively charged particles in the dust will be attracted to the side that is nearer to the screen. Okay, so how, Ray, your first part of the answer is correct. Let me read the rest of your answer. Okay, how Ray, you'll get full 3 marks. Well done. Yu Ting asking me whether dust is a matter. Okay, dust is not a matter. It's just like when you have two, okay, Yu Ting asked a very good question. If dust is not a matter, then why the electron can move? A small amount of it will move lah. But in a matter, all the electron can move. Okay, but in a non-matter, a small part of it might be able to move. Even I'll not give you the full marks. Huh? Okay, so let me explain a little bit to you. Yes, you are right. Dust is not a matter. So by right, when it's not a matter, the electron and the proton are not supposed to move so much. Okay, but because we also learned before, light charges attract, light charges repel, a very small amount of it will actually move. Okay. And because the dust particle is very, very, very light, this small amount of attraction will cause the dust to actually move towards the screen. Okay, but if the dust is actually not light at all, okay, has a very massive mass, okay, that is not possible for the small amount of attraction to actually move the dust. Okay, you understand what I'm explaining so far? Okay, so what happened here is this, your dust, okay, after moving near the, okay, when it's near the screen, on the left side, there'll be a bit of negative. On the right side, it'll be slightly positive. Okay, so it's still neutral. Then why would the dust move to the left? Okay, it's still neutral, ma. Plus and minus will attract, plus and plus will repel. So it shouldn't move to the screen. But why, even though some of the electron move to the left, it still move to the screen? Why is the reason? Okay, so can you all please explain? How we explain very well. How about the rest of you? Any one of you still need help? Okay, so when the dust is near the screen, the negatively charged particles in the dust will be slightly attracted to the screen. So the side that is nearer to the screen will be slightly negatively charged, while the side away from the screen will be slightly positive charge. So this is what happens next. So with this kind of configuration, why will we move to the screen? There should be the same amount of attraction and the same amount of repulsion, right? So why does it move to the screen? What is the theory here? Because if left side has 3 negative and right side has 3 positive, the force should cancel out. So why does it still move towards the screen? Anyone know why? Or you all still need help? Okay, I use the green color ink to give a hint. Why would the dust still move towards the screen even though the number of negative and positive charges are still the same? Chelsea, I'll give you 2 marks for your explanation. How many of you still need help? Okay, Haori, can you share your answer with everyone? Okay, share your answer with everyone. I will type out Hao Rui's answer and put on the screen. And then I will make his answer better. Okay, the answer you see on the screen here is by Hao Rui. So let me improve his answer a bit more. Okay, sorry. Okay, so that's the first mark. The neutral dust particles come closer to the positively charged screen. The electrons in the dust particles will move towards the left side. Okay, because they are attracted to the positively charged screen as unlike charges attract. Okay, therefore, the left side of the dust will be negatively charged and the right side of the dust will be positively charged. Okay, then the last part is the important part that most of you did not mention. Because the distance between the negative charge and the screen is closer, the attractive force is greater compared to the repulsive force. Okay, so the attractive force is more than the repulsive force. Okay, so the resultant force will be attraction. Okay, is that clear, everyone? If you are clear about this, give me a thumbs up. If you are still confused, give me a no reaction. Okay, and then you can use the picture in the exam. You can actually draw all these plus and minus onto this diagram to help you explain better. Okay, everybody okay? I'm losing my voice. Okay, now do part B. B question 1 and 2, they are just 1 mark each. So do not take too long. Okay, you all may begin. Anybody need help for this? Type help in the chat. Okay, this is a 1 mark question for both. Both questions are 1 mark each, so don't take too long. Okay, Chelsea, can you explain why there is a downward force? Even in physics, you don't say similar in charge. You say like or unlike. Okay, but even I'll give you the full 1 mark. Okay, Chelsea, I also give you the full 1 mark for part 1. But I need to explain a bit better why there is a force of repulsion. Chelsea, I'll give you the 1 mark for part 2, but your answer can be explained better. Okay, later you look, just take note of the answer. Okay, so you still get it correct, but you can still improve your answer. Ray, there is no increase in mass. Okay, there's only increase in force. Okay, so I will not give you the mark for part 1. Okay, quickly, the rest of you, quickly give me your answer. Okay, Ray, you must remember, mass is the amount of substance in the body. So the amount of substance in the body did not increase for both the rods. Okay, so when you say that, your answer becomes wrong. Okay, it's not because there's more mass, therefore there's more weight. Okay, that's not correct. There is more force, there's more weight because there's actually more force acting on it. And the force is not due to gravitational force. Okay, you mentioned increase in mass reading. Okay. Ray, when you say increase in mass reading, then it makes more sense. When you say increase in mass, definitely is totally wrong. When you say increase in mass reading, then it becomes not so wrong. But your mass doesn't increase in this case. Okay, so let me share with you the answer. How about the rest of you? What's your answer for this? Ryan, Oscar. Oscar, today you're very quiet. What happened to you? Okay, so can you see for part 1, that is how I answer the question. Is that clear to everyone? Okay, even you don't use the word move, even though you're not wrong, because when there's a force, there will be acceleration. Then when there's acceleration, there's movement. Okay, so but the better way to answer is there is a force. Okay, the glass rod experience a force, and the force is, yeah. Okay, so can you all just write down like this? Okay, so for part 2, you can write down like this. The plastic rod is able to exert a force on a charged object, okay, without contact. Is that okay? Okay, the plastic rod is able to exert a force on a charged object without contact. So before we go today, I would like you all to, okay, the essay question for today will be this. Okay, since you are this question, can you tell me what is an electric field? Okay, so can you tell me what is an electric field? And then anybody have any question for me today, whether this topic or other topic? Anyone give me a reaction, yes or no? Okay, if you have no question, okay, you have no question, okay, tell me what is an electric field and then give me a rating for today's lesson. Once I call your name, you may go. Okay, Yiting, well done. Oscar, well done, you may go. Anybody got any question for me regarding this topic or any other topic that you want me to Hao Rui, well done. Hao Rui is experience and electric force. Okay, you may go, Hao Rui. Any one of you have any question for me? Remember, give me a rating for today. My voice is totally gone. Okay, thank you, Hao Rui. You may go. Qiao Xing, electric field is not electric field of a charge. So can you delete the word of a charge? And then there's no exert. Okay, it is basically it is a region where an electric charge experience an electric force. Okay, can you rewrite that again? Yufan is there's no physical field. Can you recall again before I share with you the answer? Okay, Ryan, you may go. Okay, so for Yufan, let me share with you the answer. Electric field is a region where an electric charge experience an electric force. Can you remember that? Okay, electric field is a region where an electric charge experience an electric force. That's all. Okay, Chelsea, you may go. Thank you so much. If you have no question. Okay, so for Yifan, write down the statement, and then after that, you may go. Okay, thank you everyone. Have a lovely day.